Good morning all. Shishadripuram First Grade College in association with Shishadripuram Educational Trust has organized this online classes or virtual classes for benefit of students. As a part of Shishadripuram First Grade College, I thank SCT for this opportunity. So let us discuss about the topic today, protoplast. So protoplast is a cell without cell wall, basically the plant cell. We basically try to remove the cell wall from a plant and the material what we get out of it, that is called as protoplast, and it's always negative in its charge. Now the importance of this protoplast is we can obtain somatic hybrids, we can also obtain hybrids. So what is somatic hybrids, what is hybrids? I'll discuss as I enter into the topic. Now what is important here is how we extract the protoplast out of the plant cell. We have different techniques like enzymatic method, we have mechanical method. Once we have isolated the protoplast, the next what we try to do is we try to fuse them. So fusion of protoplast in order to get a somatic hybrid, it's an important step to get a new variety of plant. How we do it, let us discuss now. Fusion of protoplast can be divided into two classes. One is electrofusion chemical method. So when it comes to matter of electrofusion method, we use electricity in order to fuse two different protoplasts. As we have already discussed about the electrofusion topic, so today let us discuss about chemical method. Chemical methods can be divided into three important classes. They are basically sodium nitrate technique, high pH calcium ions, Pike method, or it's also called as polyethylene glycol. So chemical methods or chemical mode of fusion, they are quite important because the availability of chemical is very high. These chemicals will help in fusing two different protoplasts so that we get a somatic hybrids. Now let us discuss about sodium NaNO3 method, that is sodium nitrate method. Sodium nitrate method was first developed in the year 1970. So what exactly is this method? So we all know that protoplasts are negatively charged molecules. So if I try to bring two different protoplasts, so the only process what happens is repulsion. So in order to neutralize this repulsion, we started using NaNO3 method, high calcium ion method, as well as polyethylene glycol method. So in this, we have an equation called as NaNO3, which gets dissociated into Na plus NO3 minus. The sodium ion, which is a positive molecule, this molecule helps in neutralizing the charge which is present on the negative protoplast. Once the charges are neutralized, they come very close to each other. So as we bring the molecules very close to each other, at a temperature of 37 degree for 30 minutes, next we go for a technique called as centrifuge. The repulsion force is being neutralized now by sodium ions. So once the repulsion is being neutralized, we go for a centrifugation process. Now this centrifugation process will basically break the plasma membrane wherever the protoplasts are in close contact. So this is one of the important technique, and the success rate for this was somewhere around 20 to 40%. Moving on to the next technique, which is called high pH calcium ions. This was a technique which was developed in the year 1973. Okay. So now what is the role of this particular method, or what exactly this high pH calcium ion tries to do? Again, in this technique we have something called as calcium chloride, which gets dissociated into Ca plus Cl, it's 2Cl minus. This calcium ion again has the same application path as sodium in sodium nitrate method. The basic steps here includes high pH, incubation, as well as the ions. So calcium ions will try to bring the molecules very closer. So again this has an incubation period of same 37 degrees off for 30 minutes. But when compared to this and this, we have something called a centrifugation here, but we don't have centrifugation. The process of joining is done by high pH. We maintain them at a very high pH, somewhere around 9 to 10. So this pH will try to dissolve the joining point of plasma membrane. So once the joining point itself is dissolved, the cytoplasm can be exchanged, the nucleus can be exchanged to form a somatic hybrids. Along with this, we also have another technique called as polyethylene glycol method. So yeah, I forgot to tell you, the success rate is somewhere around 35 to 50%. That means the somatic hybrids what we get from this technique is 20 to 40%. From high pH calcium ion it is 35 to 50%. Now what was the necessity for the next technique, which is called as polyethylene glycol method? Polyethylene glycol or PEG. It is one of the important technique which was developed in the year 1980. Polyethylene glycol, it's a molecule which has very high molecular weight. It's a non-toxic molecule as well as it's a laxative. So basically a 37% polyethylene glycol solution is sufficient to get different kinds of heterokaryons. Now what is heterokaryons? Heterokaryons means it's a somatic hybrid which has the product of two different nucleus. I will be drawing a diagram now, so there you will come to know in a better way. So a 37% polyethylene glycol solution is mixed with parent A, parent B, that is protoplast 1 and protoplast 2, in order to get a somatic hybrid. So this is one of the important technique which is used even today, because the success rate is more than 70%. We use single chemical which is non-toxic. Technique is like we take 37% solution, take protoplast 1, protoplast 2, try to combine, incubate a period for 45 to 90 minutes. Again this depends upon the type of protoplast what we use. Some protoplast may give you result for 50 minutes, some would take a time of 75 minutes. So this is the mode, or we basically call it as starting as well as ending temperature in which you get the success rate. So now what exactly is the fusion of protoplast, how exactly it happens? Let me try to erase this. So this is parent 1 or protoplast 1, parent 2 or protoplast 2. When we try to combine, bring them very close, we neutralize the charge, which is done either by electric method or chemical method. So next what we have is the fusion which is happening. Again the nucleus are present in the respective. So the dots what you can see in the second one is now the cytoplasmic content has entered into the second protoplast. So I've got a big cell now, protoplast, where you have two separate nucleus. Furthermore, the charges in this would be neutralized so that we get a complete big cell which has two nucleus which gets combined, and this is called as heterokaryon. And the product what we are getting this
is called as somatic hybrid.